We've been talking a little bit about how to glue multiple processors together. We did pipelining, and that got us a faster clock rate, but at some point we run into the power dissipation problem and we stop. So we're not pipelining. You're not gonna see machines with more pipelining in them. We're sort of maxed out on the clock rate of a single core these days. Superscalar, well, it's at its practical limits. We've sort of taking a standard program, we can issue up to about 8 instructions. After going to a 16-issue machine simply would not provide you with any faster execution, even though it would take a lot more transistors. SIMD actually works really well, H.264 encoding and decoding. So for particular applications, we build SIMD processors in to every processor chip these days because they work so well in interesting application areas. VLIW, everything goes back to software, but it's inflexible, and people have been able to make it work very well. Okay, there are some interesting models out there. Your brain has a very slow clock rate. The rate at which your synapses fire is pretty slow. On the other hand, it seems to do a lot of processing. Right? And so there's clearly some secrets to massively parallel architectures that we all carry around with us, or at least examples of it, even though we don't really understand quite how it works. So there's obviously some room for improvement. How do we take a low clock rate piece of wetware but we're able to do all this very complicated audio visual processing, pattern recognition. We're doing all these marvelous things with really pretty shitty computation. And we're interested in figuring out what the hardware analog of that is. So there's a lot of things that remain to be done about thinking about how to build large parallel machines, and that's really your job. My generation spent a lot of time taking a traditional single-threaded, simple RISC machine and making it faster and faster and faster. We've sort of gotten to the limits of that, other than making these big multi-core things. Okay, and we need some new ideas about how parallelism should really work, like in your brain, to see what the next generation of processing is. So I look forward to a 6004 student driving up in their long stretch limo and stepping out and said, those processors you're using? I invented those. And you can take me to lunch. I'll be glad to go with you. So.